equal to s cube Laplace of f of t minus s square into f of 0 minus s into f dash 0 minus f double dash 0. Okay, so power of s is decreasing, s cube, s square, then s, is not it? So if you consider or if you continue in this process also by method of induction, we can check or we can prove this, that Laplace of nth derivative of f of t, Laplace of nth derivative of f and t, sorry, nth derivative of f of t, sorry, Laplace of nth derivative of f of t will be equal to s to the power n into Laplace of f of t. You can compare with this. If it is triple dash, it is starting from s cube. Similarly, if it is nth derivative, it is starting from s to the power n. So s to the power n Laplace of f of t minus power of s will be decreased by 1. So s to the power n minus 1 f of 0 minus s to the power n minus 2 f dash 0. Then derivative will be increased. Derivative of f will be increased 1 by 1. Means order of derivative. So s to the power n minus 2 f double dash 0. Then likewise minus dot 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 s into n minus 2 derivative of f 0 minus f n minus 1 0. Because here it is triple dash and it is ending with double derivative. So it is nth derivative. So it will be ending with, it will be end with n minus 1 derivative of f. Right? So you can use this formula in solving some problems or in solving the differential equations also. So first we will solve one example, that is Laplace of t sin omega t. Laplace of t sin omega t. So can you find this using the formula, using this derivative formula? So how to solve this? So consider this as f of t. Consider this as f of t. So t sin omega t. So f of t is equal to t sin omega t. F of t is equal to t sin omega t. So if f of t equal to t sin omega t, then f dash t will be what? According to your product formula. According to product formula. So derivative of sin derivative of t into sin omega t plus derivative of sin omega t into t. So sin omega t, so derivative of t is 1 plus then derivative of sin omega t, it is cos omega t, then again into omega, so t is multiplied. So omega t cos omega t. It is nothing, only product formula. Now again take its second derivative, that is again sin omega t, derivative of sin omega t is cos omega t into omega, then plus omega, then again product formula t into cos omega t, so cos omega t minus omega t sin omega t, and if you open this bracket, you multiply omega in this bracket, it will be omega cos omega t, here one another omega cos omega t, so it will be 2 omega cos omega t minus omega square into t sin omega t. So in the second derivative we got again this. So this part is what? T sin omega t, what we consider f of t. Right? So in the next line we can write f double dash t is equal to 2 omega cos omega t minus omega square into f of t. For t sin omega t we can write f of t. Now since we got f of t, take here Laplace on both sides. So if you take Laplace on both sides, it will be Laplace of f double dash t, then 2 omega is constant, so 2 omega, then Laplace of cos omega t minus omega square is constant, so Laplace of f of t. Okay, so now since it is Laplace of f double dash t, according to this derivative formula, it is triple dash. Derivative formula is what? Laplace of f double dash t. Laplace of f double dash t is equal to what? A square into Laplace of f of t minus s into f of 0 minus f dash 0. Is not it? This is the formula. This is the formula. So here we got what? A square into Laplace of f of t minus f of 0 minus f dash 0. and that is equal to Laplace of cos omega t. Laplace of cos omega t. So that by the formula it is what 2 omega is already there. So s by a square plus omega square. S by a square plus omega square. So 2 omega s by a square plus omega square minus omega square into Laplace of f of t. Okay, so now if you solve for Laplace of f of t, because we want Laplace of f of t, finally we have to, our objective is to find Laplace of f of t. So if you solve for Laplace of f of t, then what will be this? So to find this, before find the solution, or to find the solution, we need to find what is f of 0 and what is f dash 0. So since we consider f of t as t sin omega t, from this we can find f of 0. So if we put 0 here in place of t, it will be 0 into sin 0, that means it is 0. So this part will be 0. S of 0 equal to 0. Now again f dash t, this is your f dash t sin omega t plus omega t cos omega t. So if you put 0 here, it will be sin 0 minus 0 plus omega into 0 means 0. So it is again 0. It is again 0. So therefore, what we got? This term is 0, this term is 0. Then solve for Laplace of f of t. Then solve for Laplace of f of t. So what is this? Laplace of f of t, here it is a square, here it is minus omega square. So take it to the left hand side. Take to the left hand side. So it will be Laplace of f of t equal to 2 omega s divided by a square plus omega square is there. Again it will be a square plus omega square. So it will be a square plus omega square whole square. So Laplace of f of t equal to 2 omega s divided by a square plus omega square whole square. Right? Clear? Can you solve like this? Okay, fine. Now let's solve one initial value problem, that is y double dash minus y is equal to t, and the initial conditions are y of 0 equal to 1 and y dash 0 is equal to 1 also. Okay, so using Laplace transform, how to solve this initial value problem. So it is very important. So check this. So using Laplace transform, so take Laplace transform on both sides of this equation. Laplace transform of the equation on the left hand side as well as in the right hand side. So it will be what? Laplace of y double dash minus y is equal to Laplace of t. And using linearity principle, we can separate this. So Laplace of y double dash minus Laplace of y is equal to Laplace of t. Now Laplace of y double dash, using the previous formula, that is Laplace of f double dash t is equal to what? A square into Laplace of f minus f of 0, s into f of 0 minus f dash 0. This was the formula. This was the formula for f in case of f, but in here in place of f it is y only. Okay, so just write y in place of f. Just write y in place of f. So what is the formula? A square into Laplace of y, a square into Laplace of f. So it is Laplace of y minus s into y of 0, s into y of 0 minus y dash 0 minus y dash 0 minus Laplace of y. Okay, something here it is minus Laplace of y, so it is minus Laplace of y is equal to Laplace of t mane in the right hand side is 1 by a square. Now here Laplace of y and Laplace of y. So from these two terms you can take Laplace of y and whole into it will be a square minus 1, and for this term y of 0, the value it is given from the initial condition, y of 0 is equal to 1 and y dash 0 is also 1. So you can put these values. So minus s into 1 means minus s minus y dash 0 is 1, so minus s minus 1 is equal to 1 by s square. Okay, now solve for Laplace of y. Our objective is what? Our objective is to find y only. So to find y, just solve for Laplace of y, then we can take its inverse to find y. So therefore solve for Laplace of y. So if you solve for Laplace of y, what we will get? 1 by s square. Take these two terms to the right hand side, so it will be s plus 1, and s square minus 1 is multiplied here, so it will be divided in the right hand side. It will be divided into on the right hand side, so it will be 1 by s square into s square minus 1 plus s plus 1 whole divided by s square minus 1. Clear? Now that is equal to 1 by, so this term you can separate like this using partial fraction, so it will be 1 by s square minus 1 minus 1 by s square plus, here it is s plus 1, so it is s square minus 1, so s square minus 1 square, so s minus 1 into s plus 1, so s plus 1 will be cancelled, so only remaining part is 1 by s minus 1. The remaining part is 1 by s minus 1. So now you can take, to find the y, you can take Laplace inverse on both sides. Take Laplace inverse on both sides. So it will be what? Y is equal to, here it is Laplace of y, so in taking inverse, only we will get y on the left hand side is equal to Laplace inverse of 1 by s square minus 1. Then second term, Laplace inverse of 1 by s square, because from the linearity principle we know that Laplace inverse satisfies your linear property. So you can separately operate Laplace inverse also. So Laplace inverse of 1 by s square minus 1, Laplace minus Laplace inverse of 1 by s square, then plus Laplace inverse of 1 by s minus 1. It's easy. So now you can use the direct formula also. 1 by s square minus 1. So whose Laplace transform is this? Sine hyperbolic t. Sine hyperbolic t. Then 1 by s square. So whose Laplace transform is this? It is t. Then Laplace inverse of 1 by s minus 1. So whose Laplace transform is 1 by s minus 1? It is only e to the power t. Okay. So this is the answer. This is the answer. Okay. So clear all these things. So now try to solve some more problems, some initial value problems, and some problems which will be solved using your derivative formula. Okay, so try yourself some problems so that you can be clear more. Okay, so thank you. We'll meet again in the next lecture. Thank you all.